Hi everyone. In the last sessions, we have seen insertion operation and we have discussed about insert first and insert last. Now in this session, we'll be discussing inserting a node after any given node, right? So in this operation, we are going to perform these operations. And the first operation is first step is we need to check whether single linked list is empty or not. If single linked list is empty, we need to print some message that list is empty. Whereas in case of insert first and insert last, we are checking whether the linked list is empty or not. If at all linked list is empty, we are inserting a node as a first node or as a last node. But in case of this, the aim of this insert after function is to insert a node after a given node. So in this function, if it finds the list is empty, then we need to print some message that list is empty, and there is no question of inserting a node in case of insert after and insert before. Suppose the list is not empty, there exists some set of elements in the list. Then in that case, we need to read the node value after which the user want to insert, and then we need to search for that node in the list. That means we need to accept a node value after which the user want to insert, and after accepting that node value, we need to check whether this node value exists in that list or not. If node is found, that means whatever the node that we want to insert after and that node is found, then we need to create the node and insert that node after that node. Else if node is not found, then we need to give some message that node is not found. That means one simple point here is in case of insert after, we need to accept the node value which the user want to insert after that node. After accepting that node value, we need to check whether that node value exists in the list or not. If node value exists in the list, then we need to create a new node, and that new node should be inserted after that node value. If node value does not exist in the list, we need to give some message to the user that no node exists with that value. Like that, we need to check the thing. First condition is we need to check whether list is empty or not. Second thing is we need to check whether node exists in the list or not. And third thing is if node does not exist, we need to give some message that node does not exist in the list, right? So this operation that we are going to perform, and how we are going to perform, let us go with one simple example here, right? So check whether the linked list is empty or not. How to check it, right? At the time of declaring the structure itself, we are assigning start pointer has been assigned with what? Null. That means when we executing this program or when we are running this program, if we call this insert after function, and in that insert after function we are checking one condition that if start equal to null means, then we can simply say that what list is empty. That means no nodes are there in the list, right? So what if at all start contains null means, simply we will be giving message that no nodes are exist or list is empty. Suppose the linked list is there like this. We have what? Three nodes. We have what? Three nodes in which the first node address is stored in what? Start pointer, right? Now I would like to insert a node after any node. Let us assume that I would like to insert a node after 20. So what I need to do is I need to read the node value after which the user want to insert. That means first of all we need to read the node value after which the user wants to insert. And how I'm going to read? So you already know with the help of scanf we are going to read the data. So I'm using here scanf. I'm storing taking some value from the user, and that value I'm storing in some variable called what? N. Some variable called what? N. Here in this case I would like to insert a new node after 20, so that I'm going to enter 20, and that 20 has been stored in a variable called what? N. Has been stored in a variable called what? N, right? So now what we need to do, we need to search whether this 20 exists in the linked list or not. If 20 exists in the list, then we need to insert a new node after 20. If 20 does not exist in the list, then we need to say that no node exists with that value, right? Here 20 exists in the list as a second node. So in order to insert or in order to find whether 20 exists in the list or not, we'll be going with this code, right? So what we'll be doing is we'll be coming from first node till that 20 node, or till the last node, right? Till the last node. We'll be coming from first node till the node we find, or else till we reach it to the last node, right? Like that we need to traverse the list. So for that purpose, again we'll be assigning start to what? Temp, so that our temp is pointing to what? First node. And after that, after temp is pointing to the first node, we need to check the condition in while loop that temp not equal to null. So temp contains what? 1000. So 1000 not equal to null means condition is going to be true. If that condition is true means, then what I need to do is I need to check the data part. I need to check what? Data part, right? Temp arrow data, what we have here? 10. So 10 is equal to 20 or not. If at all 10 is equal to 20 means, if that condition is true means, then I'm going to enter into the if part. If that condition is false means, I'm going to enter into the else part, right? So what does if part contains? What does else part contains? As I said earlier that if node value found in the list, I need to insert. If I want to insert means I need to create the node. After creating a node, I need to establish the links. If what I did not find the node value, so what I need to move from current node to the next node. So how I'm going to move from current node to the next node means, here the condition is going to be false. Temp arrow data is equal to n means 10 is equal to 20 means condition is what? False. Condition false means it doesn't goes to the if part, it goes with what? Else part. In else part, what's the instruction I taken? Temp is assigned with temp arrow link. Right now the temp is pointing to the first node, that is 1000, and this 1000 link, 1000 link contains what? 2000. 2000 is assigned to what? Temp. So temp moves from first node to what? Second node. After moving temp from first node to second node, again we need to check the while loop condition that temp is not equal to null. That means temp is pointing to second node address is 2000, so 2000 not equal to null. Condition is what? True. Condition true means enters into the while loop. Inside this while loop, again if else is there, if condition is true means if part will be executed, condition false means else part will be executed, right? So what is the condition that we have in if part? We'll be checking the data part of temp, that is temp arrow data. Temp arrow data means currently temp is pointing to 2000. So 2000 arrow data, what we have? 20 and 20. And what's the node that we are searching for? We are searching for a node called 20. So 20 is equal to 20, condition is true. Condition is true means it enters into the if part. Inside this if part, what I place here, inside this if part, what I place here, I place what? Create new node, insert it after temp. That means temp is pointing to the second node, and whenever we find the data that we are searching and the node value, if both are matches, then what we need to do is we need to create a node. After that we need to insert a node after a temp, right? So for that what we'll be doing is we are creating a node with the help of this instruction, like malloc size of struct yes link, and with the help of that we'll be allocating block of memory, and then we are accepting the data part by using scanf and assigning null to the link part, right? So and that address has been stored in what? New node. And here address of newly created node is going to be 5000, and that 5000 is stored in what? New node, right? So this is how we are creating a new node. After creating a new node, what we have in if part, we need to establish links between new node and after 20 node, right? Or else temp pointing node, right? So in order to establish the links, this is a newly created node, that was the linked list that we have, and we need to establish this 50 should be placed after 20, and 20 node is pointed by a variable called what? Temp, right? Temp contains address of next node. Address of next node means what there here? Temp link part contains what? 3000, and the 3000 is going to be the address of next node. Now between this 20 and 30, I would like to place this 50. I would like to place this 50. So how the link should be? By seeing this diagrammatic representation, we are in a position to expect the links in such a way that new node link should contain 3000 and temp link should contain what? 5000, so that this link goes between 20 and 30 node. And for that purpose, we'll be going with this instructions. Right? And what instructions we'll be using here? New node link. First of all, what I'm doing is new node link contains null, and in the place of this null, what I'm doing is temp link part I'm assigning. Temp link part I'm assigning here. Temp link part, what we have? 3000 we have. So new node link part, in this new node link part, I'm going to take what? Temp arrow link. Temp arrow link, what we have here? 3000. So 3000 will be stored in the new node link part, so that a link will be established from newly created node to 3000 node. Newly created node to what? 3000 node. You may ask a question, right? Why we need to store temp arrow link into new node arrow link? We can store temp arrow link is assigned with what? New node. That means new node address can be stored in temp arrow link, means then what happens is we are going to lose the address of 3000. Address of 3000. If we go with the instruction first, like temp arrow link assigned with new node means, then we'll be going with what? We'll be losing that address. That's the reason whatever the address that we have in link part, that address should be stored in the new node link part. So that link will be established from new node to what? 3000 node. Now what we need to do? We need to establish a link from temp to what? New node. So what we can do is, already we have taken 3000 in link part of new node. So now what we can do is, we can remove this 3000 from here, and we can place a new node address, that is 5000. 5000 is stored in new node, and new node is assigned to what? Temp arrow link. See here, new node is assigned with what? Temp arrow link. So that a link will be established from temp to what? New node. From temp to what? New node, right? Whatever the link that we have between 2000 and 3000, that link is going to be breaked, and what will be establishing a link from 2000 node to what? 5000 node. Finally, your linked list is going to be appeared like this, right? So your linked list is going to be appeared like this, where 5000 node is going to be placed between 2000 node and 3000 node, between 2000 node and 3000 node, and your start contains what? Address of first node, right? That is how a node has been inserted after any given node, right? This is a case where you find a node in the list. Suppose you don't find a node in the list, then we need to say that no node exists with that value. And how we are saying that? Let's have a look on coding part, so that you might be understanding it clearly, right? So here I am taking one pointer, just like insert first and insert last. We'll be taking one pointer, start new node, and then we are taking one integer variable n, which is used to store the node value after which you want to insert, and that value it is going to store. And another variable that I am taking, that is f, which is initialized with what? 0. Which is initialized with what? 0. And this f will be acting as a flag variable, like it is going to decide whether the node exists in the list or not. And how it is going to decide, I will be explaining you, right? And after that, I am going to check whether the list is empty or not. And how I am going to check means, if start equal to null means, simply we can say that list is empty. Simply we can say that list is empty, and there ends the story of what? Your insert after function. Suppose if there are some nodes, then this if part is going to be what? False. It goes with what? Else part. In else part, the actual what logic of your insert after begins, and first thing we need to accept the node value after which you want to insert, that I'm storing in what? N. Now we need to check whether this n exists in the list or not. If I want to check whether this n exists in the list, means I need to traverse from first node to what? Last node. First node to what? Last node. So again, if I want to traverse from first node to last node, means we need to go with, as usual, looping statement, where start is assigned with temp, and temp not equal to null. If that is going to be true, then it ends into the while loop. Inside this while loop, again we'll be having if part and else part. If part is used to check whether the temp is pointing to the first node, means first node data part is equal to my searching node. If both matches, then enters into this if part. If both matches, then enters into the if part. If both matches, let us assume that if both matches, then enters into the if part. Inside this if part, the first instruction you can observe, we are taking the value of f as what? 1. That means if it is going to execute if part, means the value of f is going to be changed from 0 to 1. 0 to what? 1. If it doesn't execute this if part, then the value of f remains as what? 0. Value of f remains as what? 0. Here the value of f has been changed to what? 1. After that, if I find my searching node, then what I need to do? I need to create the node and establish the link. So that's the reason I'm creating the node with the help of malloc function, and then I'm going to accept the data part, assigning null to the link part. After assigning null to the link part, now it's the time to create a link between a new node and temp. So as already discussed, that temp arrow link should be assigned to what? New node arrow link, so that a link will be established from new node to what? The node which present after temp. The node which present after temp. After establishing the link, now we need to establish a link between temp and new node. Temp link should contain what? New node, right? So after establishing the links, I'm giving some message to the user that new node is inserted after %d node, that is temp arrow data, and then break. That means we need to stop the process. If links has been established, and if allocating block of memory and establishing the links, means then we need to come out of the loop. We need to come out of the loop, right? So after coming out of the loop, what happens? We'll be checking the value of f. So we would like to insert a node after 20. We find that node, we entered into the if part, and we made the value of f from 0 to what? 1. So here the condition is going to be false. So in this case, no node exists with that value. No node exists with that value. That was a message that we got, right? Suppose, let us go back to while loop statement here. While loop statement here. What happens is, my n value is going to be 200. Let us assume. In the linked list, I have 10, 20, 30, 10, 20, 30. So that what happens? Always the if part is going to be false. First, the value of n is going to be what? 200, and my value, first node value is going to be 10. Here the condition is false. It doesn't enter into the if part. It goes with what? Else part. In else part, what we have? I'm moving what one instruction, that temp arrow link is assigned with what? Temp. So that I'm moving from what current node to what? Current node to what? Next node. Current node to what? Next node. After moving from current node to next node, again that next node value is going to be what there? 20. 20 is equal to what? N value is what? 200. Condition is false again, and it doesn't enter into the if part. If it doesn't enter into the if part, it goes with again else part. In else part, we'll be moving from what? 20 node to what? 30 node. After moving from 20 node to 30 node, then 30 node is going to be the last node, and 30 is equal to what? 200 means condition is false. It doesn't enter into the if part. If it doesn't enter into the if part, means it does not changing the value of f. It remains the value of f is going to be 1, right? So after that, we'll be making the temp value is going to be what? Null, because last node link part contains null, and that null has been assigned to what? Temp, and now this condition is going to be false. Null not equal to null means condition is going to be false. It comes out of the while loop. That means there are two ways are there to come out of the while loop. When the while loop condition is going to be false, when while loop condition is going to be false, when it is going to be happen if we are not able to find a node in the list. If you are not able to find a node in the list. And second case is that if you find a node in the list and with the help of break, it comes out of the while loop. After coming out of the while loop only, we are checking this condition, the value of f is equal to 0 or not. See, inside while loop, if part is executed means the value of f is going to be changed to what? 1. Inside while loop, if part is not going to be executed means the value of f remains as what? 0. That means if part is executed means we find the node. If part is not executed means we did not find the node. That is how the f value playing an important role here, right? So we'll be checking the condition that if at all the value of f is 0 means, then we'll be printing that no node exists with that value. If the value of f is 1 means, then it is not going to be executed, right? So this is how insert after is going to work in case of what? A single linked list. Now in coming video, I will be coming up with insert before and how to insert a node before any node, and the same conditions will be following in case of insert before. Some little bit modifications, the coding part will be somewhat different, right? Thank you.